Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. In this video, I would like to do frame analysis using moment distribution method. Okay, this is frame example with solution. Okay, so let's look at the diagram. This is the diagram. So this is actually frame. Okay, by looking at the geometry, we know that it is unsymmetry and this frame is not properly restrained. It's improperly restrained, so this is Sidesway frame. So this Sidesway frame has combination of FEM due to loading due to 25 kilonewton per meter, as well as due to Sidesway due to delta. Okay, the objective to analyze frame using moment distribution method is to calculate the member and moment in the frame using moment distribution method. So by using moment distribution method, we can actually list the procedure, okay, in 4 steps. Okay, step number 1, we need to calculate K, the stiffness factor for each element as well as distribution factor. Okay, stiffness factor, we use 3 EI/L for far and pin or roller, and we use 4 EI/L for and fixed, internal support and rigid joint. Okay, that is step number 2. So this okay, after that, okay, by using stiffness factor, we need to calculate distribution factor. Distribution factor is equal to member stiffness divided by joint stiffness. Okay, distribution factor. Okay, this distribution factor will be used in both analysis of frame, analysis of non-sway frame, table number 1, and analysis of Sidesway frame, table number 2. Okay, we move to procedure number 2, step 2. Step 2, we actually have to do non-sway frame analysis. Okay, this is actually part where we have to analyze the end moment using in the table 1, actually table 1. And then in this procedure, we need to, number 1, make sure that the frame is held from Sidesway. We have to put an artificial support, so with that support there will be restraining force, and of course we should start with FEM, because FEM is the first member and moment in the table, and then we start distribute the moment. Okay, we do the process distribution and then carry over the value, okay, until the moment reaches 0. Then we will start distribution. We will stop distribution. And we will find the summation. Okay, the summation moment, and it is called as M0. That is for step number 2, or procedure number 2. For procedure number 3, we will only focus on table number 2, where table number 2 is actually Sidesway frame analysis only. So we have to calculate FEM by assumption, actually, okay, due to delta, where delta is unknown. Okay, this is called as frame with Sidesway frame analysis. Okay, in this frame we actually analyze the frame, not the real frame, but not the direct one, but we analyze indirectly. Okay, by introducing another frame which is proportional with, okay, the frame, okay, the frame with delta, because in this frame we have to have R prime, delta prime, and the moment is called as M prime. Okay, that is step number 3. Okay, and then we have to calculate distribution. We have to assume F, and then do distribution process. Repeat the same process again, the same as 2A process, except the FEM value is different. Then we get M prime from table, and then by using the end moment, M prime value, the n moment in table number 2, we will calculate R prime value. So the last step is, the final procedure is actually we apply what is called as principle of superposition. We apply the formula we derive. Okay, we have actually calculated all the values, including M naught, M prime, R and R prime, and we need to substitute into this procedure, this step, and we find the final n moment in the frame. Okay, so we move to step number 1 first. Step number 1 is, okay, to calculate K for each element. Remember that there are 3 elements, element AB 8 meter, element BC or member BC. Member BC is 6 meter. This is B. And member CD is 5 meter. 5 meter. So okay, so we have 3 elements. So we have KAB, element number 1, KBC, element number 2, and KCD for element number 3. Okay, so we have KAB, which is equal to, because all is rigid. Okay, all B and C is rigid joint, A and D is fixed. So we will use all element. The formula for K, we will use K EI over L. There's no 3 EI over EI here, because there's no pin N, okay, or roller N in this example. Okay, so we have AB, it is 4 divided by 8, because EI is set constant. 4 EI over 8, it is 0.5 EI. And then KBC, okay, for beam BC, it is 4 EI over 6. It is equal to 0.667 EI. And then we have element number 3, KCD. KCD, it is 5 meters, so it is 4 divided by 5 divided by 5 EI. It is equal to 0.8 EI. So from this K value, we will actually continue with calculating distribution factor. So there are 6 distribution factors, okay, depending on how many n. If we have 3 members, we have 6n. So 6n, so we have 2 n condition, NA and ND. Okay, NA is fixed, so DFAB is equal to 0. And D is also fixed, it is equivalent to 0. Okay, so the rest, DFBA, BC, CB, CD, we have to calculate. What I want to tell you is actually distribution factor is equal to 1 for all joint, except we can except fixed n. So we can call like that. Okay, all distribution factor for each joint is equal to 1 except n fixed. So that is why we can get from here, okay, distribution factor for BA. For BA means we have to calculate 0.5 divided by 0.5 plus 0.067. 0.667, so we get 0.428. So once we have determined the value for DFBA, we can calculate DFBC directly using 1 minus 0.429. 1 minus 0.429, so we get this. Actually, if we want to calculate, it is 0.667 divided by total 0.5 plus 0.667. We also get 0.572, because total this must equal to 1. The total distribution, the total means that DF at B, DF at C, total must be 1. 0 only at N fixed. Okay, so same goes to CBCD. So CB is 0.667 divided by 0.667 plus 0.8. So we get 0.455. So to determine the value of the FCD, it is just like 1 minus 0.455. This is equal to 0.545. So this is also 1. the total must be 1. So we move to step number 2. Step number 2 is non-sway frame analysis. It is called as non-sway frame analysis. So how is the frame look like? How is the frame look like? This is the frame look like. This is how the frame look like. Okay. So we remain all loading. Except we have to put an R here. Okay. We have to put an R at C. Okay. Negative direction. Okay. In negative direction. It is actually due to the artificial support. Okay, artificial support at C. So this is due to an artificial support at C. Okay, so based on this, we will continue to calculate n moment. But before that, we have to start with FEM. So FEM, so by looking at member AB, there is no FEM. Please remember that FEM, we calculate the value whenever the member has loaded. Okay, AB, there's no value, there's no force subjected on member. So the value is 0. So BC, so it is subjected to W. Okay, it is subjected to W. This is B. Okay, subjected to W. Okay, BC. And CD is also 0. So the reaction at support A and reaction at support D is actually the free body diagram for this frame. Okay, so we need to calculate only FEM for member BC, and it is negative positive because of the behavior. Negative positive because of the behavior. The behavior is like this. Okay, then the moment we push both end so that the beam will go back to straight position. So we will get negative 75 and 75. Okay, it is behavior. We cannot assume the direction. So having this fixed end moment, we have to move to step 2B. Okay, step 2B and step 3B is actually the same, except under step 3B, the FEM will be different. Okay, this is table number 1, where the first moment we get from external loading, which is UDL along member BC. So we get negative 75. Okay, we get negative 75. Okay, we get negative 75 and 75. So by putting this FEM, so next step is distribution. The next step is distribution. Okay, the next step is distribution. First must be in the table, after FEM we start with distribution, we end at distribution. Start distribution, stop at distribution. Okay, so we find the distribution moment. Okay, the distribution moment, it is total moment at B. So in this case, total moment at B is equal to total moment at B is 0 plus negative 75. We have to change sign. Change sign because we need to represent the opposite condition. Means that the value that we distribute is 75, not negative 75. Okay, because we have to plus this FEM and then we change sign. Okay, so the value, the change sign process is happen before we distribute moment. So it is 75 times 0.428, 32.1, and 75 times 0.572, we get 42.1. Okay, and then we need to do the same for C, and then we carry over. Okay, carry over, since all is rigid joint and fixed, so we have to time with 0.5, and we bring the value to the opposite side. Okay, so that is under the blue color. Okay, so this is one cycle, distribution carry over. So what we need to do is we need to repeat the process repeat the process. So for distribution number 2, it is distribution number 2 we get from 17.063. Okay, time is 0.428. Time is we get 7.303. Okay, as long as this value, when we plus this value, okay, we will get 0. 303. 303. When we total this value, it is equal to 1. When we total this value, we get not 1, we get 0. We get 0. Okay, we get 0. So we repeat the process until the moment reaches 0. So normally we will stop whenever we find the 0.0 something like this. 0.068, 0.0, negative 0.073, 0.091, negative 0.087. Okay, so wait. Okay, in this table, actually, as I mentioned just now, we need to stop at distribution. We need to stop at distribution means that okay, let's check what is the last distribution value. It should be another line. Distribution value, it is 0.073 times 0.428. 428. Okay, we get 0.03. Here is 0.031. Okay, and 0.073 times 0. It is 572. 572. This is 0.042. This is 0.042. Okay, another one is 0.091. It is negative. Time is 0.455. Okay, it is 0.041. Okay, and then 0.05. 0.05. So okay, so it is 42.1 plus another 0.031. So we get 42.1. 42.1. Okay, it is 42.1. 42.131. Okay, and then 42.2 we minus by 42.2 plus, it is 42.2 plus 0.042. 42.2. Okay, not affect much. Okay, but okay, doesn't matter. Okay, another one is 56.3 plus 0.041. This is 59.3 as well. 341, and it is 56.2 plus 0.05. 0.05. 56.25. Okay, and 28.1. Okay, so actually we can actually use the value actually must be equal to 0. For example, this MB must be equal to 0. And this MC must be equal to 0. One negative, one positive. Okay, so we will check with the Excel first. Okay, Excel. We will check whether the value is correct or wrong. Okay. Okay, so we will recheck the answer. Basically, the answer that we get from Excel is more accurate because, okay, whenever we choose up to maybe 1 decimal places or 2 decimal places, it will actually affect the value. Okay, so what we have is okay, so we have AB. We have AB, we have BA, and then we have BC, we have CB, we have CD, we have DC. The factor is 0, 0. Okay, this is 0.428. This is 1 minus this. Okay, 572. Is it the right one? 572. Okay. And this is 0.455. So we get 1 minus 0.455. Okay. When we want to set Excel to calculate, we have to put equal first. So it is 1 minus this. Okay, so the FEM is BCCB negative 75 and 75. Okay, 75 like this. So the first distribution will be, okay, I want to put different color for different joint. Different color for different joint. So this is for joint B. Okay, this is for joint C. Okay, so okay, so it is negative. It is negative plus negative 75 times 0.428. 0.428. Okay, so we get 32.1. 32.1. Okay, then we get it is 0 plus 75. Okay, times with distribution factor. Okay, so this is negative. It is 75 plus 0 time with 0.455. Okay, it is 75 plus 0 time with this. Okay. Okay, check. 40.875, 34.125, 42.9. Okay. So carry over. Carry over, we have to, okay, cross. It is cross, right? Okay. 42.9 cross boundary. Okay. This is also need to cross boundary. And this is also we need to cross boundary. Okay. So we repeat. Okay. 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 So this is distribution carry over. Okay. Clear the last. Okay. Carry over. Because the total. Okay. The table must be started at distribution, stop at distribution. Okay, we will find the total. Okay, this is actually the right value. Okay, this is actually the right value. It is 21.05. It is 42.1, 56.2, and negative 28.07. Okay, it is. So this is negative. This is negative. Negative value 56.2. Okay, it is 56.2. Okay, so this answer is acceptable, doesn't matter, it is acceptable. So we continue with restraining force calculation, R value. So to calculate R value, we must analyze the sides, the non-sway frame. Okay, by actually draw the free body diagram by putting the reaction at the support, especially the horizontal reaction. So this part and this part, because what we need is shear equation, and shear equation is equal to total Fx is equal to 0. Total Fx is equal to 0. Okay, so we write the equation by considering all horizontal reaction. All horizontal reaction and horizontal forces in the diagram. Okay, because shear reflect with column. Shear reflect with column. Okay, shear reflect with column because column is column is vertical, and delta is horizontal. So we want in the horizontal direction, and it is shear. If we compare with column, so we write the shear equation so that we can get R formula or R equation. So by looking at the diagram, so we focus on all horizontal forces and horizontal reaction. So having these four horizontal reaction and horizontal forces. So we can write the shear equation, which is equal to total Fx is equal to 0, and this is equal to 100 minus R plus Ax minus dx equal to 0. So we rearrange this, we get R equivalent to 100 plus Ax minus dx. Okay, so now in this equation we have two unknown. Unknown number 1 is Ax, unknown number 2 is dx. Means that we have to analyze, okay, column AB to analyze Ax and column CD to analyze dx. So Ax and dx will be determined using column analysis. So we get this. Okay, so this is for AB, and this is for CD. Okay, AB and CD. So in free body diagram for element AB, so we just analyze this using static equilibrium. So using that we can get Ax value by taking moment at B. This is just simple calculation like what we analyze simply supported beam. Okay, it is as simple as that. So we get 7.9 kilonewton. 7.9 kilonewton. And then for member CD, okay, it is the same thing, except we put the value from the table for CD and DC, and we will get this. And this dx is actually come from the main diagram. Okay, the main diagram that we write the shear equation. Okay, referring to the above frame. Okay, so by using static equilibrium, okay, by taking moment at C, then we can get dx value, and dx is equal to negative 5.62. Okay, and after getting Ax and dx, we need to substitute into our equation. So we have 100 plus Ax minus dx. So it is equal to 113.52 kilonewton. So we have settled step number 1 and step number 2. Okay, now we will move to frame with Sidesway frame. Okay, this frame is tend to move to right direction, and this is frame which is proportional, okay, with the frame in the principle of superposition. So all label in this frame we must change to prime. So we have the diagram. Okay. Okay. Don't forget, we have to complete this free body diagram. Okay, we have to complete the free body diagram. Okay, in order to write the shear equation. So we have subjected to R prime. So only R prime. So here we have this is Ax, prime. This is dx prime. Okay, so for the shear equation, we can straight away write the equation first if we want. So shear equation is fx is equal to 0. In the right direction, we assume positive. Okay, so we get r prime, okay, plus ax prime minus dx prime. So this is equal to 0. So this will be the shear equation. The shear equation. Okay. So what we need to understand is we have delta. We have delta, and when frame is tend to move sidesway to the right direction, what we have is the angle that is called as delta prime. Okay, it is delta prime. Okay, and we can assume it is delta prime for both. Okay, delta prime for both. So we will get okay, this will be the delta prime. Okay, this will be the delta prime. Okay, delta prime. In this case, EI is constant. In this case, what we can conclude, okay, is EI constant. Okay, delta prime also constant. Okay, what is not constant? It is length is not constant. Not constant. Okay, so what we need to do is we have to apply formula. We have to apply FEM. Okay, apply FEM for one column. Okay, for one column, and find the FEM for the other column. So the total length is okay 8 and 5. 8 meter and 5 meter. 8 meter. So this is 8. This is 5 meter. 8 meter and 5 meter. 8 meter and 5 meter. So we need to assume FEM. Okay, this is assumption. Okay, FEM. Okay, for AB equal to FEM for BA. This is equal to negative 100. So this is kilonewton meter. Okay, this is assumption. This is assumption. Okay, now if we want to calculate the FEM for member, so this is A, B, C, and D. Okay, so I want to calculate here AB. This is BC. Sorry, CD. Member AB and member CD. Member CD. In this type of frame, whenever both column are straight, so it is okay. We can only calculate FEM for column only. There's no FEM for beam. Okay, so okay, we apply formula. So formula to calculate FEM due to delta is 6. It is 6 EI delta prime. over 8 square. And for CD, it is 6 EI delta prime over 5 square. That is the formula. That is the formula. And next is assumption. Assumption to the FEM. Okay. So the FEM, so the assumption, okay, that we choose, the value that we choose is negative 100. Negative 100. Okay. Please remember the concept of FEM due to delta. Okay, because in the diagram we have we can have actually the angle which we measured from original position to new position. Original position to new position. So this is positive angle. Okay, I want to write in the formula. So for the formula, the angle representing by this positive in the formula, and the between the angle and FEM must be perpendicular. So we can check, okay, FEM is negative because the angle is positive. Okay, now we will find the ratio. So find the ratio. Okay, this is the simplest method to actually calculate the FEM for another member or another column related to negative 100 that we have assumed. Okay, so it is 6 divided by 8 square. It is 6 divided by 8 square. It is 0.0, it is 0 0.09375, and another one is it is 6 divided by 5 square, 25. It is 0.24. Okay, now we will calculate this value. Okay, I name it as X. Okay, what is X value? So using interpolation, it is 100 times 0.24 divided by 0.09375. 9375, so we get X is equal to 256. 256. Okay, 256 kilo Newton meter. Okay, so this is the value that we should put in the table. Okay, which is equal to FEM for CD. Okay, so this is actually FEM for CD equal to FEM for DC. Okay, so now we will substitute the value into table number 2, and since I have prepared the table in Excel, so I will only use that one to calculate the end moment for table number 2. So it is negative 100. Okay, but before that, remember that X must be negative, so we have to put negative. Okay, we have to put negative. Okay. Okay, we have to put negative. Doesn't matter if we want to replace. Okay, we can also replace this as as negative 256. 256. Okay, It is negative 256. So this 100 and negative 256, we have to actually substitute into the table under FEM. Okay, remember that both must be negative because of the behavior. The angle is positive. So FEM both must be negative. Okay, so we move to table. Okay, I want to change the value. It is negative 100 and negative 100. Okay, this is 0, this is 0. And we get negative 256 and negative 256. Okay, so the value that we get from the table, okay, is all this. Okay, means that we need to repeat this process. We need to repeat the distribution table. Okay, we need to repeat this process. Okay, the difference is only due to FEM. Okay, then we get the new value. The moment in table number 2 is labeled as M prime. So M prime, okay, from I can shorten as this from table 2, okay, M A B prime equal to negative 90.4. Negative 90.4 kilonewton. Okay, and M B A prime equal to negative 80.9. Negative 80.9. This is kilonewton meter. This is moment. And MBC prime equal to 80.9 kilonewton meter. One negative, one positive. Okay, and then we have 123.5. We have 123.5 CB 123.5 kilonewton meter. 123.5. Okay, 123.5. One positive, one negative. One positive. So this is positive first. One positive, one negative. One positive, one negative. So MCD is equal to negative 123.5 kilonewton meter. Kilonewton meter. And MDC is equal to, this is all prime. Okay, this is equal to negative 189.7. Negative 189.7 kilonewton meter. Okay, this is actually we get from table number 2. So, from table number 2, okay, by having this, okay, we have actually write the shear equation. Okay, this is the shear equation, remember? Shear equation. Okay, so we need to determine the AX value and DX value. AX prime and DX prime. So we have to calculate, to analyze column. So, column analysis. Okay, we have okay, this is A and B. Okay, moment at A is negative. Moment at A is negative. Moment at B, BA is also negative. Okay, the value is okay, the value is 90, 90.4 and 80.9. So we have okay, force reaction A x prime. So this is 8 meter. So we need to apply total moment at B is equal to 0. Total moment at B is equal to 0. So this is equal to negative 90.4 minus 80.9 minus 8A x equal to 0. So we get AX equal to negative 90.4 minus 80.9, we divide by 8. So this we get, it is 90.4, 80.9 divided by 8. So we get 21.41 kilonewton. Okay, that is for column AB. So we do the same for column CD. Column CD we have, okay, this is 5 meter. Okay, we have C and D. Okay, we have dx prime. We have moment one, both are negative. So negative. So it is negative and negative. Okay, at C we have 1 to 3.5, 1 to 3.5, 1 to 3.5 and 189.7. 189.7. So by taking moment at C equal to 0, taking moment at C is equal to 0, so we get negative 1 to 3.5 minus 189.7 plus dx 5 dx prime. Okay, then we will get dx equal to 1 to 3.5 plus 189.7 divided by 5. So this we get 1 to 3.5 plus 189.7. 189.7 divided by 5. 62.64. 62.64. Okay, this A prime x and dx prime. Okay, we substitute into the equation, into the shear equation. Okay, so this A and D, okay, substitute Okay, into shear equation. Shear equation. Okay, into shear equation. So, okay, we have R prime is equal to, okay, we get from, okay, the shear equation. So R is equal to, okay, let's check back. R AX is plus. AX is plus. R prime is plus, AX also plus, minus DX. Minus DX. So R means AX minus DX. Again. It is, okay, R is equal to D minus A. It is D minus A. It is D minus A. So this is equal to 62.64 minus A 21.41. Okay, 21.41. So this is equal to 64.64 minus 21.41. It is 43.23 kilo Newton. So now we want to move to procedure number 4. Procedure number 4, step number 4. Okay, this is actually the equation only. The equation only. Okay. So this is step number 4. Okay, this is step number 4. Okay, step number 4. In step number 4, if we want to find the end moment, the final end moment. Okay, the final end moment M final equal to, okay, equal to M naught plus okay, R Bye. Okay. Okay, this is step number 4 to calculate the final M moment. The final M moment, M final or M total, it is actually we get from principle of superposition. Okay, it is M naught plus R divided by R prime. It is R divided by R prime times with M prime. Okay, time with m prime. So we get m naught plus r. R value is okay 13. It is 113.52. 113.52. It is 13.52 divided by 43.23. Okay. So this is m prime. So what we get is the equation m final equal to m naught plus, okay, plus 113.52 divided by 43.23. It is 2.62663. 2.663 m prime. M prime. So the final end moment m, okay, the final end moment we get m naught. We have m naught, we have m prime. So we now want to calculate m final. M final. So we list again. Okay, we list again the okay. It doesn't matter. Okay, actually I want to list all the members here. Okay, it is AB, BA, BC, CD, BABC, CB, CBCD, CD, DC. Okay, so M prime. Okay, we get for example for AB we get negative 90.4, negative 90.4. Okay, for AB M theta, M prime. M prime for AB is 21.1, 21.1, 21.1. It is 21.1. Is 21.1. So using formula, we will get 2.63 times negative 90.4 plus with 21.1. So the answer is negative 216.65. Okay, so actually we just need to fulfill this table. So this is actually the answer. So we have to complete this. Okay, this value, this value, this value, this value, and this value. So all these 6, okay, are the 6 member and moment in frame, in Sidesway frame. Okay, in the question, and frame is actually subjected to external loading, where we can calculate the FEM due to external loading, and the frame is also unsymmetry, so the frame is tend to move to the right direction. Okay, so this is actually the answer for this. Okay, so basically in this example, okay, we have to follow the step as mentioned here. Okay, as mentioned here. So step number 2 and step number 3 will be, okay, the main body of the analysis. Okay, because under non-sway frame analysis, we have to calculate FEM, and then table 1, okay, to get M naught, okay, to get M naught, and then we calculate R value. And then for step number 3, so I have actually simplify or show the easiest way to calculate the FEM due to Sidesway based on assumption. Okay, based on assumption. So this is actually the thing that we should really understand. Okay, this is how we calculate, okay, the FEM, okay, based on assumption that we made for one column. So once we get this, we just need to substitute into the table, and then we get the end moment from table 2. Okay, end moment from table 2. We want to calculate R prime value, we have to have shear equation. And then under shear equation, we have to calculate the AX and DX using column analysis, and then substitute the value, so we get R prime. Okay, then lastly, we just have to find the equation. In this case, this is F is equal to M naught plus 2.63 M prime. So we just need to, okay, determine the final M moment as this, whether it is in the table or you want to write one by one, doesn't matter. Okay, so that's all for this video. Okay, inshallah I will continue video another frame video, but we will analyze the incline column. Okay, all about incline column, okay, under one example, under one video, inshallah. Thank you very much. We will meet again in the next video. Assalamualaikum warahmatullahi wabarakatuh.